Hey everyone. So, welcome to your last lesson of combinatorics. Welcome to your last lesson of the entire 30-1 course all together. It's an exciting day. It's an exciting lesson. And actually, the binomial theorem is very, very fun. We're going to take a few minutes and just try to develop where it comes from, okay? I don't want you to just look at a formula and just mindlessly use it and not understand what you're doing with that formula. So we'll take a few minutes to develop it, and then we'll spend the rest of this lesson just understanding what to do with it, okay? At the end of the day, it is a formula. It is given to you on your formula sheet. I need you to know where it comes from and then how to use it properly, okay? So that's what our kind of goal is for today. So the first thing we're going to do is we're going to expand x plus y to the n for values of n from 0 to 4. So x plus y to the 0, all to the 0, I should say. That one you should already be done. Anything to the 0 is just 1. X plus y to the 1, well, anything to the 1 is itself, so that'll be x plus y. X plus y all squared, you've been doing that guy since grade 10, so I think most of you are going to be able to do this guy in your head. You should have x squared plus 2xy plus y squared. Okay, so now we get to x plus y to the 3, and maybe you can't do that one in your head, but remember, you just did x plus y all squared. So essentially, x plus y to the 3 will be x plus y times x squared plus 2xy plus y squared. So I do want you to pause me for a second and do that, because I want to make sure you can establish this on your own without me. Okay, so the answer you should have gotten was x cubed plus 3x squared y plus 3xy squared plus y cubed. Then I want you to take that guy and we're going to multiply it by x plus y one more time, and that's going to tell us what x plus y to the 4 is, right? X plus y all to the 4 would be x plus y to the 3 times another x plus y. So if you already have x plus y to the 3 right there, multiply that by x plus y. So multiply every term by x, multiply every term by y, and then combine like terms again. And that will give you x plus y all to the 4. So pause me and try that. And then you got x to the 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4. So now we could keep going, but we're not gonna. We're gonna stop here and we're gonna try and establish some patterns. Okay, so the first thing I want you to look at is to look at the number of terms in the sequence. So when x was 0, sorry, n, when n is 0, which is the exponent out here, when n is 0, there's one term. When n is 1, there was 2 terms. When n is 2, there are 3 terms. When n is 3, there are 4 terms. When n is 4, there are 5 terms. When n is 100, there are 101 terms, okay? So the first thing I need you to see when we do these expansions, remember this is called binomial expansion because a binomial just means 2 terms. So that x plus y is our binomial, and we're expanding that. We're multiplying it by itself over and over and over and over and over again, okay? So if, no matter what n is, we will always have one more the number of terms than what n is, okay? That's the first thing I need you to see. The second thing we need to talk about is the sum of the exponents. So for n equals 0, the sum is 0 because there is no degree there. There is no exponents. For 1, the sum of the exponents on each term, well, this has an exponent of 1, so the sum is 1. This has an exponent of 1, so the sum is 1. Okay. On the 2, for this term, remember it says for each term. We're not adding all the exponents together. We're adding just the exponents per term. Okay. So for this guy, I've got 2. For this guy, I've got 1 plus 1, which is 2. And for this guy, I've got 2. For this guy, I've got 3. 2 plus 1 is 3. 1 plus 2 is 3. And 3. Okay, so what we're noticing is for every term, the sum of the exponents adds up to n. Okay. Okay, next thing I need you to look at is the coefficients. Now, this is a little harder to see, so what I'm going to do is I'm just going to pull all the coefficients out of here, and I'm going to write them in this little space here. So for the first guy, the coefficient was 1. In the second guy, I had a 1 and a 1. In the third guy, I had a 1, a 2, and a 1. In the next guy, I had a 1, a 3, and a 1. And then in the last row, I had a 1, a 4, a 6, a 4, and a 1. Okay, and now I want you to look at this array of numbers and see if you can see any pattern. So any number that you want, let's pick on 2 for a sec. Any number that you want is actually the sum of the two numbers above it. Okay, so 2 is 1 plus 1. The 4 right here is 3 plus 1. The 6 is 3 plus 3. Okay, so you could tell me right away what this next row would be. It would have to be a 1, and then a 5, and then a 10, and then a 10, and then a 5, and then a 1. Okay, now, since I just wrote that, you actually could now tell me x plus 5 to the all to the 5 as well, without actually doing all this multiplication. Okay, what I want you to notice is one more thing here, and then I'm going to talk about this triangle a little bit more. But since we're right here and I've written down those coefficients already, x plus y all to the 5. If I wanted to expand that now, just by following all of these patterns, we talked about the sum. Well, okay, we talked about the fact that we need 6 terms. You agree with that guy? We talked about the fact that the sum of the exponents in every term would have to add up to 5. What we didn't talk about, though, is the pattern of what they're doing there. Take a look at the first term. The first term is x. Let's just pick on this x plus y to the 4 for a sec. I went x to the 4, x to the 3, x to the 2, x to the 1, x to the nothing. So the first term starts at the highest exponent and works its way down. The second term does the opposite. It works at the lowest exponent and works its way up. It starts at the lowest exponent, sorry, and works its way up. So this would be y to the 0, y to the 1, y to the 2, y to the 3, y to the 4. So if I wanted to expand x plus y all to the 5, I already know my coefficients are 1, 5, 10, 10, 5, 1. And so then I go, this is x to the 5, x to the 4, x to the 3, x to the 2, x to the 1, x to the nothing, y to the nothing, y to the 1, y to the 2, y to the 3, y to the 4, y to the 5. And so I end up with, there's my expansion. Okay. Okay, now back to this array of numbers. Let me just clear the ink here. Back to this array of numbers for a second. This is a very special, very famous array of numbers. It's called Pascal's triangle. Okay, the pattern you're seeing is rather famous array of numbers known as Pascal's triangle. The first row is when n equals 0. And this dude here is Blaise Pascal. Okay, now some of you may have already started questioning me in the middle of this video because I know you talk to me all the time and you say, Hill, you're an idiot. Well, I talked to you during this video. Why is this in perms and cons? What does this have to do with anything? Well, Pascal's triangle is actually, the whole thing can be written using combinatorics, okay? So first of all, just take a look. Here is that last row of Pascal's triangle that we were just talking about. Okay, so that one's already there for you. But then if we looked at this using combinatorics, n, what we do is we start with your n, and then we choose none, then we choose 1, then we choose 2, then we choose 3, all the way up to n. Okay, so if I picked on when n was 4, I choose 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4. Okay? And so what this allows us to do is maybe I don't want to do the whole expansion. Maybe I just want to find one term in the expansion. Okay, maybe I want to find the 5th term in the expansion. Well, since I've circled the 4s here when n is 4, if I want the 5th term, 1, 2, 3, 4, 5, what did I have to choose? I had to choose 4 for that value, that r value in NCR. What if I want the 2nd term? Well, the 2nd term, I choose an n value of 1. So right off the bat, I want you to notice that the R in the NCR, the R is always going to be 1 less than the term number that you want, right? So if you want the 7th term of something, your R value, and I'm using quotation marks there because it's not going to be R in a sec, we're going to call it K, but just give me a minute. Your R value would have to be 1 less than what you wanted. So I think I just said 7. So if I want the 7th term, that R value would have to be 6, okay? All right, so where are we going with this? Well, 2 places. First of all, this is the algebraic definition of the expansion, okay? So x plus 4 all to the 4. I've got x to the 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4. We've established that. Notice that each term in the expansion of the binomial is a combination of x's and y's, or better put, I could say a combination of your first term with a combination of your second term, right? X means here whatever the first term in your binomial is, and y is just referring to whatever the second term of your binomial is. The coefficient, so in the expansion for x plus y to the 4, the coefficient of x squared y squared corresponds to 4c2, okay, equals 6. So x squared y squared is right there, and we get the coefficient of 6, but 4c2 is right there. And notice it's the 1, 2, 3rd term in. This is the 1, 2, 3rd term in. So when I want the 3rd term in, that R value in NCR has to be 1 less than the term number, okay? All right, so the algebraic definition of the binomial theorem states, don't get freaked out, this is all we're doing. Take a look at this in 3 different parts. X plus y to the anything I want. Okay, well, we start with n choose 0, n choose 1, n choose 2, n choose 3, n choose 4, all the way up to n choose n. Okay, then we take the first guy, my x's, and we start at the highest exponent. Well, the highest exponent would be n. So we start x to the n, then we go 1 below that, x to the n minus 1, to the x to the n minus 2, all the way until we get down to x to the 0, which would be nothing, and that's why that's not there. The y does the other, it starts at 0, and then we go y to the 1, y to the 2, y to the 3, y to the 4, y to the 5, all the way up to y to the k, okay? Now, this guy here is the cool guy that we want to talk about, because this algebraically says, hey, that's going to get me any term I want now, okay? We just have to establish what k is, but we kind of already have. Remember, k is my new r. This formula looked like NCR, and we're calling it k right now, and we've already talked about what that has to be, right? K has to be 1 less than the term you're looking for, okay? So if I took that and we just take it, I just want to open this, oops, sorry. I just want to open up just that formula for a sec. This is what we call the general term for any term in a binomial expansion. Now, what I need you to understand before I define what n and k and x and y are, this is for one term. This is the whole expansion, okay? But what I'm looking at right here is, what if I just wanted this guy right there? Well, that is term 2, right? This would be term 1, term 2, term 3, term 4, term 5, and term 6, okay? So if I just wanted term 2, I would want that to say t to the 2, because that's what, or t subscript 2, a better way of saying that. The second term, if I want that little subscript to be 2, k would have to be 1. So k is always going to be 1 less than the term number that you're looking for. So n is the power of the binomial, x is your first term of the binomial, y is your second term of the binomial, and k is 1 less than the number that you want. So if you want the third term, k is 2. So really what we're going to do for the rest of this lesson to get together is we're just going to practice how to work this formula. Okay, this doesn't do a whole expansion, it just does one term. So say I wanted to do, say I wanted to expand something to the 100th, and n is 100. You'd have to use this formula 101 times, right? Because there'd be 101 terms there. This gets you every individual term. Now, nobody's going to ask you to do that before you get freaked out. Instead, what we're going to do is we're going to play around with saying, hey, if I was to do the whole expansion, what's the fifth term? Or if I was to do the whole expansion, what's the middle term? Or something like that, okay? Where you just use this formula to get the one term you want instead of having to do the whole entire expansion, okay? All right. The number of terms in the binomial expansion of a plus 2 all to the b over 2 plus 2 is 11. Determine the value of b. Well, this is a lot easier of a question than what you might first look at. This guy here is my n. If n was 5, how many terms do I have? 6. Good. If n is 15, how many terms do I have? 16. Okay, so if I have 11 terms, I'm going the other way. If I have 11 terms, n must be 10. Okay, so that means b over 2 plus 2 has to give me 10. And that's just a cute little algebra problem that I solved for. So I'm going to subtract 2 to both sides and then multiply both sides by 2. And so my b value has to be 16. Okay, the next guy, oh, let me get that ink off for you. The next guy, determine the fifth term in the expansion of x plus y all to the 8. So my n is 8. My k value, if I want the fifth term, remember it says t to the k plus 1. So if I want the fifth term, if I want that to say t5, that means k has to be 4. So my n is 8, my k is 4, my x is x, and my y is y. So I start by writing down the formula. Again, this formula is on your formula sheet. You don't have to memorize it. Write it down. That's the first thing you're going to do. And then plug in everything you know. You know that k is 4, you know that n is 8, you know that x is x, and you know that y is y. Okay, so I plugged in everything I know, and now I'm going to clean it up. Use your calculator to figure out what 8 choose 4 is, and that's 70, x to the 4, y to the 4. So I end up with the fifth term is 70, x to the 4, y to the 4. Okay, 70, x to the 4, y to the 4. So if I was going to do x plus y all to the 8, and I expanded that whole thing out, I would get 9 terms. So it would look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. The fifth term right there would be 70, x to the 4, y to the 4. That's what we just did, okay? I want to make sure you have a visual of what's happening here. Okay, determine the middle term in the expansion of 2x minus 5 all to the 6. Now I've done a couple of things to you. First of all, you have to figure out what k is. Second of all, x is not x anymore and y is not y, so you have to be careful of that. X is now 2x because x just meant whatever the first term was, and y is negative 5. Make sure you're taking into account the sign that comes before that number. Now, I have 7 terms, so what is the term in the middle? Well, 1, 2, 3, 4, 5, 6, 7. Let's just pick on that for a sec. The term in the middle, term 4, okay? Term 4 is in the middle. Then I'd have 1, 2, 3 on one side and 5, 6, 7 on the other side. Okay, so term 4 is in the middle. I'm looking for term 4, which means k has to be 3. Okay, so here I go again with my formula. It says t to the k plus 1, so that gives me my t4. K is 3, so that's 6. N choose k is 6 choose 3. My x is 2x, all to the n minus k. So that'd be 6 minus 3 is 3. And then negative 5, all to the k. Okay, common mistake kids make here. Okay, don't forget that that 3, that exponent of 3 will apply to both of those guys in there. Okay, so this is now going to be 2 to the 3, which is 8, and x to the 3. Okay, then in your calculator, you want to figure out what 6 choose 3 is. And so we end up with 20, that's 6 choose 3. 2 to the 3 is 8. I got x to the 3, and I got negative 5 to the 3 is negative 125. Okay, so now remember all of this is just multiplication. So if I can take these numbers, I can simplify this just by multiplying all those numbers together. And so that would be negative 20,000 x to the 3. Okay, negative 20,000 x to the 3. That's the middle term in that expansion. Okay, good job. Now, determine, or given 5x minus 2y all to the 9, determine the value of the term containing x to the 5. So again, I didn't explicitly tell you what k was here, so we're going to have to figure that out. Think about what you do know. You do know n is 9. You know that x is 5x, and you know that y is negative 2 to the negative 2y, sorry. So if I just start with my formula, take a look at this guy for a sec. This gives me x to the n minus k. Well, the only term involving x is this guy right now. I know that n is 9. So I'm just going to write a little 9 on top there. Wow, I did that really bad, but that's a 9. Okay, if I want this to end up being x to the 5, can you see now that k is going to have to be 4? Because that would give me 9 minus 4, which would give me my x to the 5 that I want. Okay. So I know that k has to be 4, and once I know k has to be 4, I just plug that in and keep going. So I end up with 9 choose 4. I have my x term is 5x, so that's 5x all to the 5. And then my y term was negative 2y, so that's negative 2y all to the 4. Again, just be careful, that 5 applies to both items. I want to draw that out for you so that you don't forget. And that 4 applies to both items. And watch when you're putting that in your calculator, a reminder that a negative number to an even exponent is going to be positive. Okay. So I figure out what 9 choose 4 is in my calculator. That's going to give me 126. 5 to the 5 is 3,125. X to the 5, negative 2 all to the 4 would give me positive 16. Y to the 4. And then I just multiply the numbers together. Okay, so final answer is 6,300,000. X to the 5, Y to the 4. Don't get worried about large answers here. Okay, good job. All right, now this is kind of the main event of our show here, the constant term. Your diploma often likes to ask binomial theorem questions with the constant term. Now, I want to go back a slide just for 1 second because I want to make a quick connection here. This said, determine the value of the term containing x to the 5. And you did that no problem, okay? Now it says determine the constant term. That's just a fancy way of saying determine the value of the term containing x to the 0. Because x to the 0 is 1. The definition of a constant term is a term that doesn't have a variable in it. And the only way when both my first term and my second term in my binomial have x's in them, the only way to get a constant term is to end up with x to the 0. Okay, so this is just a fancy way of saying determine the value of the term that contains x to the 0. Now, there's a little bit more playing around we have to do with this guy to figure out what the k value is. Okay, so first we're going to start by writing down the formula because that's something that's given to me, and now I'm going to fill in everything I know. Well, what do I know? I don't know k yet, so I'm going to ignore that, but I do know that n is 6. And I know that my first term is 3x cubed. And I know that my second term is 1 over x cubed. Now, instead of calling that 1 over x cubed, just so I can keep it all in a straight line, I'm going to call that x to the negative 3, because that's what a negative exponent does anyway. Okay? So I'll probably do that in the next line down. But the next thing I want to talk about is essentially I need to get this guy and this guy together. Okay. Well, I can do that. You got to listen really carefully to this, because this is where all the mistakes happen. Okay. I can multiply powers of the same bases together if I just add the exponents. The problem is this 3 is locked into the x cubed. So the first thing I need to do is I kind of have to separate those into two different guys being multiplied together. So the 6 minus x exponent, sorry, 6 minus k exponent will apply to the 3, and it will apply to the x cubed. So I'm going to break those guys up so that I can deal with just the x cubed there for a second. Okay, so that's what I've done here. I've got the 3 to the 6 minus k. This guy here is a power of a power. So when I have a power of a power, I multiply the exponent. So that's where the 18 minus 3k is coming from. And then, like I said earlier, I wrote my 1 over x cubed as x to the negative 3, but then it's x to the negative 3 to the k. So I multiplied those exponents together and got negative 3k. Now, these guys are ready to put together. So when I'm multiplying powers of the same base, I just add the exponent. So this is going to become x to the 18 minus 6x. And so that's as cleaned up as I can get it for the moment until I know what k is. Well, now I'm actually ready to figure out what k is, because we said the constant term, I had to have a k value of 0. Okay, well, I've got all my x's together. If they're all simplified as much as I can, now I know that 18 minus 6x has to give me out 0. And that is enough information to figure out what k is. K has to be 3. Okay, the reason I know k has to be 3 is because that's the only number I could plug in for k and get out an exponent of 0. When I get x to the 0, my variables are gone and I'm left with the constant term. I'm left with just the number. Now, before you get ahead of yourself, lots of kids at this stage of the game will tell me, hey, why can't I just say it's the last term? The constant term is always the last term. That's not true. The constant term is the last term in a polynomial written in proper order of descending exponents. This is a different context, okay? And often the constant term is gonna not be on the last term. It's gonna be somewhere in the middle. It all depends on the weight of the exponents on the two terms that you have, okay? So don't get caught thinking it's just whatever the last term is. That's not what the constant term means here. What it means here is you need the term containing x to the 0, essentially. Okay, so we figured that out. We figured out that k is 3. So now all we do is plug the 3 in for all my k's and solve. So there I go, plugging in all my 3's. Okay, this whole thing is gone now because it equals 0. Okay, and now I'm just looking at this guy. So 6 choose 3 times 3 to the 3, essentially. So I get 20 times 27, and that is 540. So the constant term is the fourth term, and it equals 540. Okay. Awesome. All right. A term in the expansion of x plus b all to the 7 is 21,504 x to the 5 all over y to the 4. Determine the value of b. So in this one, I actually gave you the answer. Okay, I gave you what t to the n was, or t subscript n. We now need to backtrack and try and figure out what b is. Okay, so we start with the formula. I have given you this whole thing. T to the k plus 1 is this. Okay, I know that n would have to be 7. I know that my first term is x, and I know that right now my second term I'm going to put in as b, and I'll solve for b. Now, take a look at this for a sec. This says x to the 7 minus k, and I need to end up with a 5. Is that enough information to figure out k? For sure it is. Okay, so I know that x to the 7 minus k has to be 5, and that allows me to conclude that k has to be 2. Now that I know k is 2, I'll plug it in for k, and I'll plug in the 21,504 x to the 5 over y to the 4. Okay, so 7 choose 2, gave me my 21. I got x to the 5, and I got b squared. All right, now I want to clean this up a little bit. I can divide both sides by 21. I can also divide both sides by 5x to the 5, and then my x to the 5s will just divide out. When I divide both sides by 21, I end up with 1,024 all over y to the 4, and that gives me b squared by itself. To get b, I just have to square root both sides. Just a reminder though, when you square root both sides, that could be plus or minus. So my answer right now ends up being plus or minus 32 over y squared equals b. Plus or minus 32 over y squared equals b. All right, I'll take that ink off for you. Okay, given 8x to the 6 minus 7y to the 3 all to the 9, determine the position of the term containing x to the 36, then determine the term. So this is actually exactly like the constant term question, except that instead of trying to figure out where x to the 0 happens, I'm looking for where x to the 36 happens, okay? So we're gonna start with the formula, fill in everything I know. I know that n is 9. I don't know k yet. I know that x is 8x to the 6, and I know that y is negative 7y cubed. Okay, so when I fill all that in, now I want to pick on this fella for a second, because this is the only place I see x. I need x to the 36. Now, this already says x to the 6, so I need this to say x to the 6 to the 6, because I know that when I have a power of a power, I would multiply the exponents together, and I know that 6 times 6 is 36. So that 9 minus k has to end up giving me 6, which means k has to be 3. Okay, so now that I know k is 3, I go back and plug it in. And I just do the math for everything. Remember that this 6 here has to apply to the 8 as well. So 9 choose 3 ends up being 84. 8 to the 6 is 262,144. Negative 7 to the 3 is negative 343. And then y to the 3 is y to the 9. Now, I multiply the numbers together, and that's going to give me a whopping number, negative 7,552,892,928 x to the 36, y to the 9. Now be careful that you understand the answer to the question. The question said determine, first of all, the position. So the position that is that it's t to the 4, it's the 4th term. And then the term number itself was this guy. Okay? All right, awesome job. So hopefully this makes sense. Your homework is posted here. Try it, make sure that you are very neat in your work. Take it step by step. Always, always, always start by writing the formula down, figuring out who you have, who you need, take stock of that, say n equals, k equals, x equals, y equals, and then go from there, okay? If you have any questions, you know where to find me. Have a great day, guys. Take care.